Okay, great. Thanks for having me. I guess the first question before we jump in, who here has heard of eBPF? Okay, awesome. Well, somebody else can give this presentation then. So just kick off, how many people have seen this logo before? Okay, and when you see this logo, do you like think a little jingle that goes on inside your head, right? And then like how many people know the actual instruction set difference between like Intel and AMD, right? Okay, a few people, but right, if you think about the vast majority of people, this is a really recognizable logo. Everybody wanted Intel inside their laptop until now, like different story, right? But how many people actually knew what the difference was between Intel and any of the other chips that could have been there? It was the marketing, the brand. People thought it gave their laptop like more power. And so what I'm going to be laying out in the talk for you today is the exact same thing, except for with eBPF. By the end of this talk, you're going to understand that you're going to want products, you're going to want projects, you're going to want companies using eBPF, and that you're going to want them inside the products that you're using. And not because there's like a slick jingle or anything else like that. It's going to be because of the power that eBPF brings to what you're trying to do. It unlocks new ways of doing things, more performant ways of doing things, more secure ways of doing things, and all of these benefits are going to be why you want eBPF inside. So that's a lot of buzz. Is there actually any bite behind what I've said so far? So kind of rewinding before we had eBPF, we kind of had this kernel space and user space paradox. And so in the kernel, we have kind of like this full system awareness, but it's a 30-year-old technology. It's really long, hard to change things. There's not a lot of flexibility in terms of what you can do. And so that's why most of the applications we do today are programmed in user space. It's very programmable, but you don't have direct access to all these kernel structures or resources. And kind of as a way to get around that, there was kernel modules, but they're a little bit difficult, sometimes unsafe, like crashing your kernel, and not always stable. So it's kind of like, do you want the flexibility or do you want the performance and visibility? And you kind of had to choose between one or the other. And so this kind of left us, is there a way to bring programmability into the kernel? And also, how can this benefit as we're moving towards more cloud and cloud native type environments? And that's how we came to eBPF. What eBPF allows us to do is to make the Linux kernel programmable. And not only that, it allows us to make it programmable in a secure and efficient manner. The very high-level analogy that a lot of people like to use is that what JavaScript is the browser, eBPF is to the Linux kernel. And so if you think kind of like before JavaScript, you had these very static web pages, right? And so you're kind of like just consuming static information, right? And now with eBPF or with JavaScript, suddenly you're able to add interactivity into your websites, right? And so you can have buttons and clicks and stuff. eBPF allows you to do that too. It suddenly makes this one static thing into something that's programmable, that's interactive, that's flexible. And kind of what Linus himself said is eBPF is actually really useful, and the real power of it is how it allows people to do specialized code that isn't enabled until it's asked for, right? So adding this new way of doing things exactly when you need it. And so what eBPF allows us to do is not just change the kernel behavior, but actually dynamically change it exactly when we need it. And so before eBPF, let me kind of like walk through how things went. So you have your friendly application developer there, and he's like, awesome, I have this new application. I want some new way to observe it. And so he walks over to his friendly Linux kernel developer, and he says, you know, it'd be awesome if you could just add this new feature to the Linux kernel. You know, it should be pretty easy. I can program things and like ship it the same day. And the Linux kernel developer says like, okay, like let me just have a year so I can convince the community that this is like a really good idea and it should be shipped to billions of devices worldwide, right? And then so 1 year later, okay, great, now the upstream kernel supports it, Linux kernel developer is done, but then the application developer says like, but I need this actually in my distro now. And so 5 years later, when that kernel actually ships to the Linux distro and is an LTS release, he said, wow, you can finally have it. It's in the distro that you want. But in the preceding 5 years, the complete needs have changed, and we're on to a different front-end framework. So now, that was kind of like the old version of you if you're trying to upstream things into the kernel, right? And now with eBPF, this is the new world. So application developer, I need this new feature to observe my application. eBPF developer says, no problem, let me solve this really quickly. And a couple days later, here's the release of our eBPF project. It has the new feature, and you don't even need to reboot your machine. And actually, like, this is a real world case study that I've heard people talk about before. I think my favorite one is Brendan Gregg, who helped popularize eBPF and did a lot of upstream work. He was talking about how in some of his meetings at Intel, customers would be asking him questions about like how they would do different performance type things. And he'd be able to write up a program in the meeting and answer their question by the end of the meeting, right? And so rather than having this year-long development process, you can answer questions, add new functionality by the end of your meeting. And that's a pretty powerful technology, right? And that's exactly why Brendan Gregg calls it superpowers for Linux. And that's why I think you're gonna want this vision of eBPF inside, because you're able to add new functionality exactly when you need it, and you're able to do it in days or weeks instead of years. So what eBPF allows us to do, right, there's a lot of magic, but it's not only kind of all the fun side, it also allows us to do it in a safe and performant way, right? Kernel is a very important space for us to take care of. It's very key to how the system works. And so eBPF does it in a safe and performance way, so we're not crashing the Linux kernel. Right, and so the way that eBPF programs work is they're running on events, right? So they're not used until they're actually called for. So you insert these little programs into your kernel, and then when something's like a process tries to read something or connect to something, then when that happens on this specific point in the kernel, then your eBPF program runs. So these aren't something that are running all the time in the background, consuming resources. They're only used exactly when you need them. Right, but as I said before, Linux kernel is a very kind of like critical part of your system. So a really big thing is safety. And this is where the eBPF verifier comes in. And so before you can load any eBPF program into the Linux kernel to modify how it works, there's actually a verification step. And what this does is check things like the program's gonna run to completion, it's not gonna crash or otherwise harm the kernel. There's kind of some limits on what the programs are actually able to do. And this is to make sure that your kernel doesn't hang or other things happen. And then the verifier also checks that the default now is that only privileged users are allowed to load eBPF programs, because obviously you probably don't want untrusted users running untrusted code in your kernel. And then once it's kind of been passed as it's safe by the verifier, then the next part is kind of the performance side. So in the kernel, it's like JIT compiled into a machine-specific instruction set, and so it basically has the speed of native kernel code, which is pretty powerful technology too. This is actually one of my favorite graphs, talking about kind of like the power of eBPF for performance. And so on the left side, we have eBPF, and on the other side was IPVS. And this is actually a graph from a production Grafana instance. And when they switched over their load balancer, they actually thought they broke it because the graphs are obviously so different. And I thought that was quite a cool story about really how much more powerful eBPF is in terms of performance. And then, right, so now you have all these programs running in the Linux kernel. They somehow still need to talk to user space. And so you're able to do that through things called BPF maps. And what this allows us to do is to share different data or structures between user space and kernel space. And this allows us to do this in a very performant way and without losing data too. So that's the really quick run through of how eBPF works. So where is actually eBPF today? So when we think about like kind of like cloud computing, I'm from like the cloud native world, so I like to think about a lot of things in terms of Kubernetes. And the way that Kubernetes works is you have a bunch of containers running in user space, doing a lot of different things, and they're all calling into the kernel to access the hardware and the resources of the systems, things like run this process, read this file, make this network call, right? And the kernel, because it's providing access to the resources of the system, it's aware of everything that's happening on the host, right? It can see all the pods running inside of Kubernetes, any malicious pods that people are trying to run outside of Kubernetes. It sees everything because everything has to make calls through the Linux kernel, right? And that means that these eBPF programs can see everything that's happening too. You suddenly have a shared system that everybody is accessing. And so you have one essentially control point where you can insert the eBPF programs to do exactly what you need to on the system. And the best part about this is since this is running in the kernel and it's seeing everything that's happening on the system, you don't actually need to make any changes to the code or configuration of your applications because eBPF is seeing everything that's happening. And so going back to the kernel space, user space paradox we were talking about before, what eBPF now allows us to do, it allows us to have the benefits of having things in the kernel in terms of performance and visibility, but now it brings that flexibility that we were asking for too into the Linux kernel. And it does that safely in a performant manner, full observability, and programmability. And the best thing is, it's available by default in most major Linux distributions now. So where is eBPF today? Is this something that people are actually using or a faraway technology? So I work at Isovalent. I'll start with kind of the examples that I know the best is in terms of networking. So I work on a project, I'm a maintainer of an open source project called Cilium, and this provides eBPF-based networking. And it's used by all the major cloud providers. It's used by hundreds and thousands of organizations around the world. And how Cilium originally began was to provide essentially container networking, right? In the cloud native world, everything's a lot more dynamic. Things are changing much more quickly. And we need a way to do more performant networking than what we used in the last generations for SDN and other things like that. And so kind of like the vision was using eBPF, do an intent and identity-based container networking built on eBPF. And that's what kind of Cilium was built around. And then kind of with the concepts of that, Cilium has now started to expand into different parts too. So it allows us to do network security based on identities rather than IPs. So that allows us to have a lot more powerful network policy and encryption, right? And that's because we can give things more abstract identities. We're able to mesh multiple clusters together. So moving things, connecting multiple Kubernetes clusters together to do more performant load balancing. Like the graph that I showed you earlier was from Cilium's layer 4 load balancer, right? Providing much more performant ways of doing networking. Then in terms of observability, there's a lot of other projects too. Things like Inspector Gadget, Hubble, OpenTelemetry, and Pixie and Packet Where Are You? These are just a sample that I'm running through right now. And so what Hubble allows us to do, right, since it's inserted into the kernel, it's seeing everything that's happening. It's able to pull the network observability information, right, essentially off of the wire, off of Cilium, to give us things like flow logs, metrics, different troubleshooting information. I think working with end users of Cilium, this is actually their favorite part of the Cilium platform because of the debuggability that it provides to them. And so it's allows us to observe essentially everything that's happening on the wire, right? And this is really critical in the world of distributed systems because in the world of distributed systems, everything is going over the network. And once we kind of have that information, then we're able to surface it into things like a service map too, right? So that's the cool thing about eBPF. You're able to collect and use a lot of information and then surface it however you need to. eBPF is also really becoming a lot bigger in security too, through projects like Falco, KubeArmor, and Tetragon. And so what we like to talk about here is security observability. So in the last part, I was just talking about security for like debugging and troubleshooting like that. But that observability information can also be used for things like security. Like, is a malicious actor trying to open a reverse shell? Are they trying to access a file that they shouldn't, right? You're able to observe everything that's happening on that system, so then you can use that observability information for security too. Not only that, but since eBPF is running into the kernel, you can also do runtime enforcement too. So an event happens, you don't want that event to happen, you can kill the application trying to do that, right? Since you're controlling everything in the actual Linux kernel. Tetragon is a sub-project of Cilium that's focused on security observability and runtime enforcement, right? So checking all the things that are happening in the Linux kernel and then being able to stop the things that you don't want to, right? eBPF is really powerful because it can hook anywhere in the Linux kernel. So you can check out things like process execution, file access, namespace escapes, privilege escalations, all these different things you're able to do because eBPF can attach to so many different points within the Linux kernel too. And then the last use case I'll talk about today is around tracing and profiling. There's a couple different projects here like Pyroscope, Parka, and Pixie. This gives you essentially a profile of how the application is running on your system. It's tracing how it goes through the kernel. Parka does a thing called icicle graphs. Brendan Gregg had a thing called flame graphs, however you want to look at it. It's kind of looking at how long does each part of what your application is trying to do actually doing, so you can optimize that and improve the actual performance of your system too. So kind of a summary of like across all these different use cases is that these eBPF tools provide us like really rich context-aware event streams. They're seeing everything that's happening in the kernel and they're able to surface that information so you're able to do and accomplish whatever you want to. So then the question, why don't we just like sprinkle a little of the eBPF magic dust on everything? Well, because it's still not a magic bullet. I think this tweet captures it really well. It's really, at the end of the day, eBPF is just a virtual machine running really small programs that can look into the kernel and do something based on that. But it's not a lot more than that, right? So a lot of these things that people try to do in eBPF, it could be replaced by things like shell scripts or reading different things. Like, it's cool. I think one of my favorite quotes recently is like the eBPF juggernaut is like taking over so many parts of the Linux kernel. I think that really captures the momentum behind the project. But the Linux kernel has also been around for 30 years. There's a lot of tools to do a lot of things, especially if you're trying to do something that has been done before, right? And so eBPF is just another tool in the toolbox, and you should think about what you're actually trying to accomplish too. Another thing that eBPF doesn't understand is, right, eBPF is running in the kernel, so it'll understand things like open file, forward packet, create a socket, right? But what your customer is actually trying to do is none of those things. What they're trying to do is add product X to my cart so I can check out and pay you money, right? And so going from what's happening in the Linux kernel towards your actual business needs, there's a disconnect there, right? You can't just like throw a couple of eBPF programs into your kernel and expect things to be better. You need to be able to translate from what's actually happening there into your business end goals, or you need to have a project that is doing that for you, right? It's not a simple technology. And eBPF really is challenging. It doesn't have the business context. Either you or the project or product that you're relying on needs to provide that to the kernel. It does require Linux kernel knowledge. If you don't have a Linux kernel team, like maybe it's not the best to start writing eBPF programs to throw onto your machines. And because it can see everything in the kernel, like the data volumes kind of around eBPF can be like absolutely absurd. You can see every single thing that's happening on your machine. Right, so all this is kind of created, like, as I said, the eBPF juggernaut, a really buzzing community around eBPF. And I think this is one of my favorite things. This is the original patch set that got merged into the Linux kernel in March 2014. So eBPF is actually 10 years old. It's been around for quite a long time. It's just like, as I said before, to get something into like a Linux kernel distribution that a lot of people use in production takes a while. So that's why you might be like, why am I just hearing about eBPF now? It's because it's 10 years old and the Linux kernel cycles are a lot longer. There's tons of projects on the eBPF landscape. I ran through like some of the major applications in the different use cases I was talking about earlier, but there's a lot more projects expanding, and this eBPF landscape is expanding all the time. I think I'm actually missing a couple projects on here right now, but go to eBPF.io and you can see every single one that's happening right now. And that's just on the application side, so translating the eBPF programs into the business logic that you're trying to accomplish. But there's also a lot of things on the infrastructure side too, like different compilers and different ways to use eBPF. So different eBPF libraries and different areas that eBPF is going to be applied to. There's also a hot acquisition market around eBPF too. A lot of companies have been acquired in this space, including Isovalent 2. We recently got acquired by Cisco. So I get the joy of switching to Microsoft Office. And eBPF is also being applied to a lot more places. This presentation has been focused mainly on the Linux kernel, because that's where it originally started, but it's expanding to different things like Windows. It's also expanding to different types of hardware too. And it's also being standardized by the IETF right now. The eBPF Foundation is also providing a lot of research funding to get academics and other people interested in driving forward the state of the art around eBPF too. So if all this got you really excited about eBPF, where should you go next? Well, like any good thing on the internet, the first place to start is Wikipedia. I'd recommend checking out the eBPF Wikipedia page. eBPF.io is also a great source for a lot of different information and also has the project landscape that I was talking about before. It's also available in 7 different languages right now, but there is not currently a German translation, so if anybody is interested in helping out with that, come talk to me afterwards. On eBPF.io, there's different labs. Say you want to try programming your first eBPF program, get your kernel to say hello world. This is a great way to get started in a hands-on environment too. eBPF is coming back this fall for the 5th edition. So if you want to learn more and dive more into the internals, this got you excited, sign up. It'll be on September 11th. It's a virtual event, so you can watch it from anywhere in the world. I run a bi-weekly eBPF newsletter if you want to keep up on what's happening in the ecosystem. And if you really want kind of the cool Netflix-style documentary of how to do it, check out ebpfdocumentary.com, and it kind of gives you the backstory of how this all came to be 10 years ago and what's happened since then. This is probably one of the funnest projects I've ever worked on, so I am very biased, but I would check it out. I also wrote a book, The Illustrated Children's Guide to eBPF, giving you a little insight into that. That's also available for download on eBPF.io. The eBPF Foundation also wrote a State of the eBPF reports. This is something that you can give to your CTO, CISOs, CIO, so they can kind of understand where eBPF is being used in production today. So kind of wrapping it all up now, I gave you a vision for eBPF inside. Hopefully this leads you to believe a little bit in that vision. And I guess maybe the thing that I'd close on is eBPF is kind of like the cloud native app store, right? When you originally got your phones, you'd be shipped a phone that's the hardware and the software included, and it only had the functionality that you had on the phone to do things, right? And the iPhone kind of all changed all of this because suddenly there was an application store. So when you needed new functionality on your phone, you could go download that on the fly, add new functionality to your phone, and do it in real time, right? So suddenly you need to get directions, so you download Google Maps. You need to get something to eat, so you download Uber Eats, right? You can add new functionality to an existing piece of hardware, and that's exactly what eBPF is doing for you too. And that is why I think you'll want eBPF inside the projects, the products, and the different companies that you work with. eBPF is going to be what you want inside the technology that you're going to be used going forwards. So thank you, and I think we have a couple minutes for questions.
Yeah. Thank you very much, Bill. Are there any questions? I start here, it's easier.
Hi, thanks for the talk. Are there any known attacks using eBPF? Because for me it seems like a pretty interesting attack vector for attackers, because you can directly inject code into the kernel.
Yeah, so you're modifying how the kernel works. I think that goes back to don't let untrusted users run untrusted code on your software. So that's why only privileged users are allowed to run eBPF programs. If the attacker already has admin, then you might have other problems.
Yeah, right.
Can you throw it in the back?
Yeah,
please.
Hey, thank you for the talk. I have like maybe a weird question, but I wonder whether eBPF like slowly turns Linux into a microkernel. I read that like you had this slide where the scheduler was very much deep into the kernel territory, and now like in the recent Linux version, the scheduler exposes, like primitives for eBPF, so you can write userland schedulers, which is I personally find amazing, but I think it's quite a step into a direction I think many people would not be happy with.
Yeah, I think this is the debate right now. I think it's a really interesting debate, and this is actually where the eBPF juggernaut kind of quote comes from, is like, if they're even taking the CPU scheduler from the kernel, like what is an eBPF going to take over? For me, I think it's exciting because I think there is a lot of the kind of excitement and the innovation went out of the Linux kernel because it took so long to get anything that you wanted to done. And suddenly now with eBPF, you're able to experiment again. And so I think one of the arguments for allowing experimentation with the CPU scheduler or other things is you can innovate and then you can take the best ideas and bring them back into the Linux kernel. And I think that's kind of the exciting part is rather than saying oh, we're gonna have to fight about this for a couple of years and then it gets merged and then all of our requirements change, suddenly you can be oh no, I'm gonna write something, I'm gonna see if it works. If it's really good, then we can bring that kind of innovation, those ideas back into the Linux kernel. So hopefully, I think this will actually improve the kernel innovation cycle for all of us.
Yeah, and democratize development, really.
Yeah, exactly.
We can take one more question? Yeah. Okay, this is a little bit challenging. Perfect.
Great. So what is the overhead of eBPF and how do you manage this overhead?
Yeah, so this totally depends on what you're doing. I think this is what I was saying. So it's a specific program only run when being called for. So the question is, how many times are you calling it, right? So if you're doing a super, I don't know, writing a lot to the disk and you're running a program every single time you write to the disk, right, then that's going to consume a lot more resources. If you're only looking for, I think actually the security use case is actually one of the really interesting ones because as long as no security events happen, then you have essentially zero overhead, right? And I think that's quite cool. I mean, the program's not running, right?
Yeah, please go ahead.
If you monitor the file system, all access to the file system, because this is how you are going to detect that something illegal is happening. Okay? So you have to monitor all file opens or file closes, etc. So
yeah, but you're not monitoring it. It's only the program is only running when that file is being accessed or whatever else is happening. In the other times, it's not running. It's not a continuous process running in the background.
No, it will run for every file that is open in order to detect if it is my file.
No, you can target it to just specific files. It's not every single one. I think this is the thing is eBPF can hook into so many different points on the Linux kernel. It can see so many different things, and so that's why the data volume can be crazy. But I think if you really want to use eBPF correctly, you're targeting to the specific use cases, the specific things you're going to do. Yes, if you try to monitor every single file open, that's going to be a lot of overhead. If you only monitor for when somebody's trying to access /password, that's a lot lower, right? Because that shouldn't be accessed that much, or basically at all. So the overhead of eBPF can actually be super low, and I think that's why a lot of people like it. And actually, one of the funniest stories I heard about eBPF is for one of the like the observability use cases, they actually had a negative overhead because it was something about like they were spacing the packets like more evenly so they could actually go through the system faster. But that was like a very edge case. So, but yeah, the overhead for eBPF can be high or it can be very low, but it just depends on how you use the technology.
Short one.
First of all, thanks for the great talk, and I'm glad to see so many knowing eBPF. Two very short comments. So one, for those who are interested in the observability, very great news for the Open Telemetry project that just added a continuous profiler based on eBPF, full host profiling. So if you want, I'm a CNCF ambassador as well, so if you have questions about that. And secondly, I think one of the challenges that we had in observability space at least is when you had and you touched about it very briefly, the business context. So for example, tracing, if I want the account ID or user ID or some of the context of the request propagating through, which is pretty standard in distributed tracing, for example, the challenge has been how you propagate it when it's auto-instrumented via eBPF, and I'm wondering what's your best practices in that regard of propagating business-related context through auto-instrumentation eBPF-based.
If you don't have the experience to do that yourself, then I would rely on a project that's doing it for you. So that's why people like the Cilium project, because they don't have to say, like, this socket and that socket and this IP. They say, I like let front end talk to back end, right? And so that's the business context. And the project is translating that into eBPF programs. So if you don't have the experience to do that by yourself, that's why I'd recommend having a project with eBPF inside and not using it yourself.
Okay, so thank you. Bill will be around for quite some time, so catch him if you can for further questions. And with that, again, thank you very much for your great talk. Thanks.